Good morning, everyone. If you're here, looks like there's one or two people. That's cool. Get started once enough people show up. I've got a couple things to talk about, and then we'll jump into systems of equations. I'm just gonna put the link on our website so people can find us if they haven't already. Okay. Oh, look at that. We got 6 people. Morning, Jomi. Oh, 9 people. Good morning, Max. Okay. Just want to add this link before I forget. Bear with me. Okay, I think I do this. Okay. We'll save this as a PDF. Actually, not yet. Not yet. Not yet, not yet. Okay. Okay, we have 13 people, which certainly isn't our full full roster, but I think that's enough to get started. Before I begin, a couple things to note going forward. There's I wouldn't say like a change. It's not so much that there's been any changes, but we have been asked to start taking attendance, and what that looks like is not a typical kind of attendance. It's not like I'm going to be sitting here with my little attendance software like in school and calling everyone's name and waiting for people to say here. What it's going to look like is exit slips. So I think going forward, and I'm not going to do that this week. I'm going to implement that next week. So like our final term. So after next week, or I guess starting next week, I will be giving exit slips for every class. And I understand that not everyone is able to watch the stream at exactly the same time. So I'll try to work around that and kind of have something like the exit slip will be due at the end of the day, like at 3:30. What's an exit slip? An exit slip is it's like a very, very miniature assignment, typically just one question, and it's not intended to be like a challenging question. It's kind of like if you showed up to class, the exit slip should take 30 seconds, just like a very, very simple assignment. So I'll start doing that next week, and I'll do that in the form of a Google form. So I'll post the link to the Google form, and in the stream I will just say the question. I'm not going to post the question on the website or anything, so you do actually have to watch the video. So I'll pose the question in the stream, probably near the end of the stream. I think that makes more sense than having it at the beginning, because ideally the exit slip should reflect what we covered in class. And I think it is also important for you to know that as far as I understand, and I could be mistaken, but as far as I understand, attendance in this sense is not going to be reflected on your report card. Attendance is more just for the school division to see how many people are actually participating in the online videos, and possibly next year looking at any kind of remedial programs for anyone who's sort of fallen behind because they weren't attending classes regularly online. So just keep that in mind, that we'll be doing that going forward. I'm curious to see if this motivates more people, because I think I have something like 38 grade 9s, and right now there's 21 of you, so you can do the math. It's just a little bit over half. So I'm wondering if maybe having exit slips and kind of some kind of attendance will have any kind of effect. If it does, great. If not, whatever. I'm just doing what I have been asked to do. So yeah, I'll be having some exit slips next week. Okay. Another thing to keep your eye on is I'd like some feedback from you just about workload and the lessons and pretty much everything. So later this week, I will be having a Google form on my website. It's not worth any marks. It's not really like an assignment, but I think it'd be a really good opportunity for you to have your voice heard by me. So I really want to just check in, see how things are going. Like I keep saying this, but I've never done this before, and I don't really know very many people who have done this. So I'd like to get some feedback from you, and not just my grade 9s, but all of my students. I'd like to hear from everyone just about workload. Like how's the homework? Is it overwhelming? Is it too much? Is it not enough? Are my videos too long? Am I rambling? Am I doing too many examples and not enough theory? Am I doing too much theory, not enough examples? That kind of thing. It's very different because usually in class we have work periods, and that's really the best way to spend a math class, is for the students to be doing lots of work. It can't just all be me. But right now, I can't think of any feasible way of having a work period where I can actually see my students working. So it does have to be kind of one-sided, and that's just the nature of this. I can't think of any other way of doing it. If you can think of a way of doing that, then let me know. Okay, I think that's all I wanted to talk about before we started. So keep in mind we'll be having the exit slips going forward starting next week. And there will be a sort of a feedback Google form type deal. If we do Zoom, we can have a work period. Yeah, I've thought of that. I have my hesitations about Zoom. Also, I think it'd be a little bit challenging because you'd have to like have your phone or whatever device you're using sort of pointed downwards towards your work, so I could see your work. That's definitely a great suggestion. I'll certainly consider that. Yeah, so yeah, we could possibly do a Zoom type of work period. I've also been thinking a little bit about group work and different ways of collaborating. If you use a computer, it could work. Yeah, absolutely. So yeah, definitely a lot of really good ideas. And that's just in a YouTube chat. So I'd love to hear from you. So I think the best way for me to hear from you is just in an organized way. Like if it's all like in a YouTube chat, then I'll probably forget, and it might be kind of disorganized. So just keep your eye on the website. I'll probably have it up later today. There's no due date. I'm just gonna keep it up on my website. So at any point, if you ever change your mind about something, like maybe you already submitted it and you want to say something else, then the form will just be on the website and you can give me feedback at any point. Okay, so yeah, we had the exit slips, the feedback. I think there was something else, but maybe not. Oh yes. Okay, yeah, something about marks. Yeah, I knew Natty would ask, because you asked on Google Classroom already. Okay, marks. Marks. So, so let's start off with the assignment, the assignment that I handed back. So you may have already received your grade on the latest homework assignment. For a final grade, how does our first semester come into effect? Okay, let me just do one question at a time. Okay, so I first want to talk about, okay, let me write this down just so I don't get distracted. Okay, so I want to talk about the assignment. So assignment that I just handed back. Then I want to talk about the next report card. So the report cards that are coming up. And then finally, the last thing is, okay, someone wants to know about final grade. Final grade. Okay, and what I'm going to do is I'm going to bring up the syllabus. Gr9 Advanced. Give me 2 seconds. I just have to pull up my my email so I can get that grade 9 syllabus. Okay. Course outline. Here it is. Okay. Final exam. Okay. Okay. So, let's first talk about the assignment. So the assignment I handed back. So I handed this back, and I say handed back because I just gave you your grade. I didn't really mark it. So this is a learning experience for me using Google Classroom. My understanding was that if I had used Google Classroom, I'd be able to use my iPad, my little fancy pencil kind of thing, and give you check marks and that sort of thing, and give you really, like a typical type of feedback. And it ended up being a logistical nightmare to do that. For several reasons. One reason is that not everyone handed it in using Google Classroom, which is no one's fault. I specifically set it up in such a way that you could either use Google Classroom or you could use the class website and just use the Google form that I posted there. That was one way, or one reason why it was difficult, is because half of the people just use a Google form, and if you just use a Google form, then your assignment wasn't loaded up into Google Classroom, and it was a nightmare to try to figure out whose assignment came from where. So I wasn't able to do that. And for the students who did hand it in using Google Classroom, it did end up being still quite challenging to use the pencil. I thought it was going to be a lot easier than it was. So what I decided to do is just give you your mark, and I'm going to post the solutions. That said, I'm still waiting for a few students to hand it in. I will post the solutions on Friday because I will not be accepting any assignments later than Friday. That would be almost 3 weeks late. So, and I mean, another good reason why I'm not going to accept it for after Friday is because report cards are due on the following Monday. So that leaves almost no time for me to mark it and incorporate that grade into your semester 2 mark, etc., etc. So you will just have to wait until Friday when I submit the solutions, and you can see for yourself where you went wrong, and you can kind of grade it yourself. Certainly not the most ideal way for me to give you feedback, but again, if I'm learning as I go. So hopefully our next assignment will go a little more smoothly in terms of me giving you feedback. But I definitely learned a lot. I think next time we'll just go through Google Classroom and see if that makes a difference for me when I actually do the marking. So there's that. So yeah, we did so that's the assignment. I think that's all I wanted to say about the assignment. Report cards. So the grade. So I will submit. I will submit grades on Google Classroom. I'll write GC. Come on, GC. Google Classroom. It's just, it's one more thing for me to do. I'll try to do it today. I can't promise I'll do it today. Hopefully in the next couple of days. So let's say by Thursday. Okay, so that by the next time you see me, that's going to be my goal, to submit your grades on Google Classroom. And the way that'll work is I will just put a sort of a blank assignment, sort of like a shell of assignment, and then I will just, quote unquote, return your assignment with your final grade. And I mean, I don't mean final grade, I actually mean your term 3 grade. Your final grade, I don't know, this is where things get a little confusing. So that's what I wanted to say about report cards. The final grade, a lot of question marks over here. I'm almost hesitant to even bring this up because there's so many questions that I still have. So in terms of our final grade, what are we going to do about our final grade? So I'll start off just by talking about the grade 9 advanced outline, which I think you would have got at the beginning of the year. Are we going to have an exam or a final assignment? So yeah, maybe this is something that I can get some feedback from you about on that Google form that I was telling you about. Is like, what can we do for like a final exam kind of a thing? So the final exam. So I'm just reading this from the grade 9 advanced outline. So semester 1 is worth twice as much as semester 2 for a combined weight of 70% of the final mark. The final exam is worth 30% of the final grade. So if we're going to stick to what the outline says, we will have some kind of final assignment or final exam or whatever that's going to look like. And that's something that, again, is up in the air. I haven't decided exactly what we're going to do for a final exam. As far as I know, it's kind of up to me. There's no sort of like Winnipeg School Division policy on final exams. I know that the provincial exams have been canceled. That doesn't apply to you because you're not writing a provincial exam, but that is relevant because the province has canceled their exams. So I don't know what I'm going to do. I really like having a final exam because it kind of wraps everything up, right? It's all the topics that we've learned throughout the whole year and kind of just consolidating it all into one package deal. So I really do like having final exams, and I know everyone hates final exams. I've been a student for much longer than you. I've written far more final exams than you, and I know how brutal they can be. That said, it's important. It is important to do a final exam. What if we have just a really small quiz? Well, that wouldn't really be much of a final exam. The purpose of a final exam is to cover all of the material throughout the whole year. So I've kind of been thinking a little bit on like in the direction of like a project, like some kind of project. But I still haven't really decided how that'll look. So definitely that's still up in the air. The only thing for sure is that nothing is for sure. So the final exam is worth 30% of the grade, and your first semester is worth twice as much as your second semester. So whatever happens in semester 2, it is worth. Okay, so let's just take a look at kind of how this works. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this is your whole grade. All of this is 100%. Your final exam is worth 30%. So I'm going to write FE, so final exam is worth 30%. And then of the remaining 70%, 2/3 of it is worth the first semester. So it's going to look something like this. Okay, so we've split that up into thirds. So this is semester 1, and this is semester 2, and then that is the final exam. So whatever we get for semester 2, that's what you get for semester 2. Semester 1 is worth whatever that is, 66% of 70%, and then the final exam is worth 30%. So so that's how the final grade is going to be calculated. What this final exam looks like, I don't know yet. But I'd like to hear your feedback. And I'm not saying that I'm just going to do whatever you write in the Google form. I'm going to consider what a lot of people are saying. So can we replace the final exam with the other half of semester 2? I don't think so, no. So think about what we can do for a final exam, and I mean, and be realistic. I'm not just going to have a short quiz or something. I am going to do something meaningful that kind of represents all the material that we've done throughout the year. Wait, but the final exam doesn't count, right? Because of the rule, though. I'm not sure which rule you're referring to. Anyway, think about that. Think about some things that you'd like to do instead of a final exam. Sorry, I'm just reading the chat. But yeah, it's not just going to be like a short quiz or anything like that. The March 20 rule. Oh, the March 20 rule. No, so that's saying that the lowest that your upcoming report card grade can be. Okay, so your final grade, your final grade is going to be the maximum of two things: your March 20th, grade, or your current grade. So whatever is the largest of these two, that's what your final grade is going to be. So that doesn't mean that we're not going to have a final exam. It just means that if you do worse on the final exam than what your grade was on March 20th, then you would just default back to the March 20th grade. Now, whatever your March 20th grade is, I'm not entirely sure how to calculate that, because I don't know if that's just from your semester 2 or if that counts towards your final grade, because your final grade is actually supposed to incorporate some of semester 1. So I'm not entirely sure how all of that sort of incorporates with each other. That said, I'm going to be looking into it, so I'll ask some of the other teachers and principals and things like that to clarify some of these rules. In any case, I'll get back to you when I know more. Okay, so that was a lot of administrative stuff. That was 25 minutes of administrative stuff, and that leaves us about 20 minutes to do this lesson. So let's talk about systems of equations. I want to talk about I think 3 ways of doing systems of linear equations. Okay, so first let's talk about what a system of equation is. Okay, so a system of equations is a group of several equations, okay? And they share the same variables. Okay? Okay, so a system of equations is a group of several equations sharing the same variables. We can solve a system of equations. I'm just going to abbreviate equations. We can solve a system of equations by finding a value for each variable, that works in every equation. Okay? Okay, so let's see what that actually means. So let's just jump right into an example. So let's look at something like this. Okay, so let's solve the following system. So let's solve the following system, and that'll look something like this. We've got y. Let's try y equals. I'm just going to borrow this one. So y equals x minus 3, and y equals 5x plus 1. 5x plus 1. So what we want a value for x and y that fits in both equations. Okay, so we want a value of x and y that fits in both equations. So like I could just sort of randomly guess some until something works. Probably not the best method. Like let's say we tried, okay, how about x equals 2? If x equals 2, then in this equation, I'm going to name these equations. Let's call this equation 1 and this equation 2. So if I look at equation 2 and say, okay, well, if x is equal to 2, then y, that means that y must be equal to, well, 5 times 2 is 10, plus 1 is 11. So that could be one possible solution in the second equation. But in the first equation, if x equals 2, that means that y must be equal to, well, we'd have 2 minus 3, which is negative 1. So that means that y would have to be negative 1. I don't think that's going to work. So yeah, so that's not going to work out very well for us. So there's several methods for solving these, and I think that you've already been introduced to these methods, but we're just going to kind of do a bit of a review. So one method for solving is to graph. So you can graph these, okay? So let's see what it looks like when we graph both of these equations. So I'm going to make a nice little graph here, okay? So, and I'll do it in orange, how about? So here's my orange graph, and so there's my x and y axis. Got some arrows here, oops. There's my arrows. And then I'll say that this is my y-axis, this is my x-axis. And I'm going to graph the first one, y equals x minus 3. So my slope is 1, right? My slope is 1, and my y-intercept is negative 3. So I've got this line here, so it's going to go up like this. Actually, I'm going to use the straight line tool. So here we go. So there's my first one. So there is the graph of y equals x minus 3. And then the other one, y equals 5x plus 1. So I've got 5x plus 1. And that's going to, so here's my y-intercept. And I'm going over 1. So my slope is 5. So my rise is 5. My run is 1. So I go over 1. I go up 1, 2, 3, 4, 5, and over 1. And I'll go in the opposite direction now. So I go to the left by 1 and down 1, 2, 3, 4, 5. There we go. And I'll sort of connect these dots here. Okay, so here is this line. Okay, and you can see I didn't quite extend this first one long enough, so I'm gonna erase part of it and keep going, and then you can kind of see where they intersect. So this point of intersection right here, this is what we would call a point of intersection. Okay, that's our point of intersection. Oh, it's a little late, but is the work from semester 1 included in the final exam? Yeah, the whole point of a final exam is that it's cumulative, so that that we'd be covering material from the beginning of the year. Absolutely. Okay. So so what we did here is we found a point of intersection for both of these lines, and what that means is we found a point in the xy plane that is on the first line. I should also name this. This is y equals 5x plus 1. So we found a point that is on both lines. So that makes it really easy for us when we want to solve this, because now we can say, okay, well, this point right here, this is the point, what is it? It is, well, -1 and 1, 2, 3, 4. So this is the point -1, oh, and -4. -1, -4. Okay, so that point is on both lines. So that means that is our solution. So our solution is x comma y equals -1 comma -4. Okay, so that's a solution to this system. So a solution to a system is, I mean, one way to think about it is using this graphing method is, can we solve algebraically if we know how? Yes, we're going to get to that. Okay, so in the chat someone asked, can we solve this algebraically if we know how? If the question asks you to solve a question by graphing, then no, you have to solve it by graphing. Okay? If the question asks you to solve it in any way you like, then use any way that you like. So it depends. The answer to that question depends on the context. If it didn't specify the method, then you can use any method you want, right? But if it asks you to use a specific method, then you have to use that specific method. So the solution here is -1 comma -4. So that's one way of interpreting these systems of linear equations, is by a graph. Okay, so let's talk a little bit about the different possibilities. Okay, so possibilities. So I'll say actually possible solutions. Okay, so so a solution to a system of equations has 3 possible outcomes. And I'm quite sure that you've done this before. I'm just trying to sort of do some review, and like we've covered most of the topics that we're supposed to throughout the year. So we're kind of cycling back and sort of spiraling from the beginning of the year. So so from this point forward, you can kind of expect to see some topics that you've already seen before. Okay, so a solution to a system of equations has 3 possible outcomes. The first outcome could be that we have one solution. And that is where you have a single point of intersection. So like if this is one of my lines and this is my other line, they intersect at a single point. Okay? And I should say a system of linear equations. So that's just straight lines. Okay? System of linear equations there's 3 possible outcomes. The first outcome is that you have one solution, and that's what we had here, right? We had 2 lines and they intersected at a single point, and that single point is your solution. The second possible outcome, and we'll see one of these at some point, is that we have no solutions. Okay? So one way of looking at that is that if you had 2 lines that are parallel, They have the same slope. I should have arrows on all of these. Okay, so there would be so I'll just say that these are, actually there's a symbol for parallel lines. I don't know if you already know that, but if I draw these two little lines here, that means that both of these lines are parallel. So that's one. Another possible outcome is that if you have parallel lines, then they never intersect, so there is no solution to this system. So you kind of have to wrap your mind around that sometimes you don't have a solution to a system of linear equations. The last outcome is infinite solutions. Infinite number of solutions, and that happens when you have the same line kind of written in two different ways. So I'm not quite sure how to draw that. I'll try maybe drawing it in two different colors. It's kind of a silly drawing there, but the idea is that every single point on each of the lines is a solution because it's the same line. So you could kind of imagine, like y equals 1/2 x, I don't know, plus 1, and maybe y equals 2/4x plus 1, right? They're different in that they have different numbers on them, but essentially they're the same line. So any point on one of the graphs is going to be on the other graph because it's, I shouldn't say graph. Any point on one of the lines will be on the other line because they're the same line. So that's the third possible outcome. So there's three possible outcomes. You've got one solution, no solution, or an infinite number of solutions. And we have to have a system in place to be able to recognize which one of these is which. So when we're graphing, it's very easy to see which one is which. In this case, we had exactly one solution, like right over here. This is our solution. We had one point of intersection, whereas you can imagine if we graphed two lines that were parallel to one another, then you'd notice that there are no solutions. But you may have to prove that the two lines are parallel. Okay. Okay. So let's talk about a different method. Okay. So, and we've got 5 minutes, so I'm not sure if we'll actually be able to cover all of the methods. So the next method is called substitution. Okay. And did I talk about, okay, so another method. I'll call this method number 2 is substitution. Okay, so another method is to substitute one variable into, or I guess I should say one variable from one of the equations into the other. Okay, and the whole idea of this one is, of this method, the whole idea of this method is that the whole point is that these two equations, they share the same variables. So they should represent the same number, right? I believe that Mr. McIntosh taught you all of these methods. I was looking through your midterm exam, and I think that all of these have been covered. So I think that you have seen all of these. So another method is to substitute one variable from one of the equations into the other. So let's see what that looks like. So let's try this one here. So this is really straightforward when you have your equation in the form y equals mx plus b. This is really nice if both of the equations are in the form y equals mx plus b, like if this is equation 1 and this is equation 2, all you have to do is take this y and put it into that y. It couldn't be any easier. So let's go ahead and do that. let's try, what is it? We'll do y equals negative 4x plus 6, and y equals negative 3x plus 5. Okay. Okay, so I've got these two equations here. So I've got this one, and they happen to be in slope-intercept form, which you may be tempted to start graphing, and maybe we can graph these as well. I'm just gonna make these look a little bit nicer. So we could graph them if we wanted to, but we're gonna use substitution here. So we're gonna substitute this. So the idea here is that we're gonna take this y, and we're going to plug it into this y. Well, what do I mean by that? Well, y in this case, y is equal, where's my pen? Here it is. Y is equal to negative 3x plus 5. How do we know? It says so right there. Y is equal to that. That's what y is. So let's take this y and plug it, and I'll use some nice little technology here. So we're going to take this y and plug it into this y. So I'm going to move this out of the way. So y is equal to y, obviously, which means that negative 3x plus 5 is equal to negative 4x plus 6. And now what we've done is we have just a single equation now, and that single equation has one variable. So one variable, one equation. Super straightforward. We can solve this. So let's go ahead and solve it. So I'm gonna bring this 4x over to the other side. So I'm gonna add 4x to both sides, and I'm left with 4x minus 3x plus 5 equals 6. 4x minus 3x is just x. So I've got x plus 5 equals 6. I'm gonna subtract 5 from both sides, and I'll get x equals 1. Great. So is that our solution? Almost. It's close to being the solution. So x equals 1. What about y? What's y equal to? Remember, we have to solve for both x and y. So the idea here is that we have two equations and two unknowns. So we've solved for one of the unknowns, or one of the variables. So let's see if we can figure out what the other variable is. So we'll have to go back. I really shouldn't have erased those equations, but I think I can recover them. So the one of the equations was y equals negative 3x plus 5, and the other one was y equals negative 4x plus 6. Okay, so what we can do now is we can choose either of these equations. Either of them. It doesn't matter which one. You can choose either of them and plug our value of x into either of these equations. And the whole point of this is that it doesn't matter which one. The whole point is that we will get the same value for y regardless of which equation we choose. That's the whole point of this, is that we're gonna get the same y. We'd better get the same y, otherwise it wouldn't be a solution to the system. So let's punch it in. So if x is equal to 1, what's y going to be equal to? Well, I'm going to have, I'll just do it all in sort of one go. I've got negative 3 times 1 plus 5. So negative 3 times 1 is negative 3. So here I've got negative 3 plus 5, and I get 2. Negative 3 plus 5 is 2. And just to be like very clear here, it does not matter which one we choose. So let's see if we choose the other equation. Let's see if we get anything different. I've got negative 4 times 1 plus 6. Well, negative 4 times 1 is negative 4. So over here we'd have negative 4. Negative 4 plus 6 is, look at that, 2. Okay, so when x is equal to 1, y is equal to 2. Okay, and that is called substitution. Okay, because we're substituting one variable into the other. So so this would be our solution. So if you want to write the solution is x comma y is equal to 1 comma 2. And if we graphed these, if we graphed both of these equations, we would find that there is an intersection at that point. So let's quickly graph this. I've got Desmos right here. And what was that first one? It's y equals negative 3x plus 5. So I'll write y equals negative 3x plus 5. Okay, that's 1. And the other one here is y equals negative 4x plus 6. So y equals negative 4x plus 6. Y equals negative 4x plus 6. Okay, and there you can see they intersect at the point 1 comma 2. So there you have it. And they only intersect in that one point, right? It doesn't, we can zoom out, keep zooming out, and they only intersect at a single point, and that point is the point 1, 2. Okay, so I'm gonna leave it at that. So that is our two methods. We can solve by graphing, and we can solve by substitution. So I'm gonna put a worksheet on the website now. I'm gonna get you to do the first 10 questions. Because after question 10, we're solving by elimination. Okay. So I haven't shown you elimination yet. So just work on the first 10 questions. The worksheet is 17 questions long. So yeah, there's that, and okay, great. So I'm gonna put that on the website now. You do not have to submit it. This is just homework. But next week there will be a new assignment that will cover this material, as well as some of the material we were doing last week. So certainly do it, but you don't have to submit it. No. Okay, yeah, I'm gonna sign out now. So yeah, stay tuned for a couple of things. First of all, stay tuned for the Google form that I'm gonna post that will sort of outline some feedback. So if you want to have some feedback, and then I guess also take a look out for your final, or not your final, but your term 3 mark, which I'll post on Google Classroom. Okay, I'll talk to you guys on Thursday, and have a good day. Yeah, bye bye.